Hello everyone, welcome back. So today we're going to take a look at how I perform the market basket analysis for my digital store. Now first, what is market basket analysis? Market basket analysis is a data analysis technique used to understand customers' purchase behavior by identifying products that are frequently bought together. So it helps retailers make strategic decisions on, the kind of products, how to do product placements and promotions, and then bundle products together. So this is ultimately to drive sales. So to perform a market basket analysis, these are what is required. First, you need to get the data source. That's you need the transaction data, which is usually the POS transactions or customers' receipts, just transaction logs generally. And then you will need to create the association rule. The association rule focuses on discovering the relationships between products by calculating three different variables: the support, the confidence, and the lift. So support refers to the number of times that a product or set of products appear in the same transactions. That's the number of times that product A and product B will be bought together invariably. That is what support is. Then confidence refers to the probability or likelihood that if a customer buys product A, then that customer will also buy product B. Then the third variable is lift. Lift means the likelihood that product B is bought when product A is bought compared to a random chance. In other words, if a customer often buys milk and sugar together, then the MBA will highlight this combo as follows. Support: milk plus sugar appears in 20% of the transactions. That's what support would indicate. Confidence would say 70% of customers who bought milk also bought sugar. If the lift is greater than one, then the products are likely bought together more often than expected by chance. That means that a lift of greater than one means that, oh, it is not a coincidence that these two products are being bought together. They are really being bought together. The chance of, milk being bought when sugar is bought is highly likely. It is not by mistake. It is not a coincidence. So invariably lift kind of, eliminates the question of chance, you know. So the products have a positive association, meaning that they are more often bought together than expected by random chance. So that means it is not a random chance that those two products are bought together. A lift of one means that milk and sugar purchased together is purely random. There's no special relationship between them. While a lift that is less than one decreases the likelihood of sugar being bought, suggesting that there's a negative association between them. So can you see how valuable market basket analysis can be for businesses, especially retail stores like supermarkets and e-commerce platforms? By analyzing the purchase patterns, they can, strategically place products frequently that are frequently bought together side by side, or they can bundle them to boost sales through psychological tactics. So for my digital store, I have transactions for the sales of tracks and then transaction for the sales of albums. So I'm going to perform an MBA on all the tracks sold as well as all the albums sold separately. So let's go over to my SQL. So first, let's go over this the formulas for the association rule. So to calculate support, confidence, and lift, this is the formula to use. For support, it is frequency of products A and B. That's the frequency of the products from each of the baskets that we're going to create, divided by the total number of transactions multiplied by 100. For confidence, it is the frequency of both products again. That's frequency of products A and B then divided by the frequency of the product on the left hand side. So I'll explain what we mean by this soon. Then multiplied by 100. So for lift it is the support of both products that we calculated here divided by the product of the support of A and the support of B. So if we want to break it down, we'll say that lift is this divided by support of A multiplied by support of B So that's the support of this divided by the product of the support of A and B. So now let's go down to our query. So this with basket as A, we are creating a temporary table called market B. So that's with market B as this. So that means that this is the query that will create this new table, but it's a temporary table, so that's why we're using a CTE. So we're going to use that temporary table to create or to find all the parameters up here. So we need all these parameters. So we're going to use this CTE to find all these parameters before we now start to calculate our support, the confidence, and the lift. So let's say I remove this for now temporarily. Let me put it here. Okay. And I'll take this out. I'll also take this out, this out, and then I want to take each line one by one. So right. Now what we want is we want two baskets to be created. We want one called initial basket and the other one called the second basket. Now we're going to create this basket from a table that I previously created. This artist albums table, which is this one, I created it from, combining or joining several tables together. So I joined the invoice items table, which is this, the invoice table, genre, artist table, playlists, media types, tracks. So all these tables were joined together to create this artist album table. And the reason for that is because I wanted everything I needed, all the columns I need for my analysis. I wanted them in one particular table so that I don't have to be going back and forth, during my analysis. So I collected everything, all the columns that I would need into this table. There's a video on how I created this table. I'm going to put a link to that video in this video's description. So we're going to get all this. We're going to create these two baskets from this artist albums table. That means that we're going to join this table to itself. You can join two tables, you can join three tables together, you can join four tables together, and you can join a table to itself. So in this case, we're going to join this table to itself. Now we want to create two baskets. We want to create an initial basket and a second basket. So the essence of this basket is to find the relationship between transactions or tracks that were bought together. We want to, kind of determine if it is a normal occurrence for these tracks to be bought together or they were bought together by random chance. In other words, we want to perform an association rule on the transactions. So for us to break our transactions into two different baskets, we need to look at our artist album table. Our artist album table is the original table where all the transactions are placed. And I explained how I came about the artist album table. Now, what we're going to do is that we're going to join this artist album table to itself. In other words, we're making the artist album seem like it's two tables, but it's just one table. So we're giving it an alias. You know, when an item when items are in the same transaction ID or in the same invoice ID, which is the case in this particular example, it means that those items were bought together. They were bought at the same time. For instance, if I go to this store now and I buy maybe three different tracks at once, my transaction ID may be 001 and I bought track A, B, and C. So what's going to happen here is that the tracks that I bought, the this is going to find possible associations between my tracks. So that means that for the initial basket, okay, the possible associations could be track A with track A, track A with track B, track B with track C. Those are three possible outcomes. That's three possible associations. That means what it's simply comparing those transactions together to see how often I buy those, I mean, how often those items are bought together. So what it's now going to do here is to create two baskets in such a way that in the initial basket, you'll probably put track A, and then in the second basket, put track B, so that it will now create an association where I compare track A in initial basket with track B. Then in the next row, it's going to be maybe track A again. And then in the second basket, in the second row of the second basket, put in track C, so that now it will now compare track A and track C. Then in the third pick that it's going to do is going to pick maybe track B, and then put that track B in the initial basket, and then put track C in the second basket, so that in that case we are now comparing track B and track C. So you're going to keep picking items from the box like that based on the invoice ID. So it's going to use the invoice IDs to identify tracks that were bought together, so that using those tracks, you will now use the tracks to split, I mean, the invoice IDs to split the items into each box. Now, if we look, that is for, like I said, assuming transaction 001. If another person comes and does another, maybe buys another set of maybe four items, and that is invoice ID number 002. The next invoice that our query will look at will be invoice 002. Inside invoice 002, there are four items. It will now create an association, let's use that word again, such that it will now compare maybe there are tracks C, D, E, F, so that we have C in initial basket, D in second basket, so that we are comparing C and D. Then in the and in the next line, it will now pick maybe item F and compare it with item D. So that means F will be in initial basket, D will be in second basket, and on. So it's going to be picking the tracks using the invoice IDs. So once it sees that, oh, in box A, that's why it's comparing the table to itself. It will look like at the table twice, so to speak. Let's put it that way. It will look at this table twice. It will look at it the first time as table A and look at it the second time as table B. So if when it looks at it as table A and picks invoice 001, it will now go, since we say the invoices should be the same, it will now go and acting as table B now, it will now go and still look for that invoice 001 and look for an item, a track name in that invoice, in that particular invoice number, making sure that whatever item it picks will not be the same as the first item it had picked for the initial basket. That's where this query comes in. We're saying that whenever you pick a track, make sure that that track is not the same as the next one you pick. That is, when you are picking a track, when you assume that the table is table A, make sure that that track you pick is not the same name, is not the same thing as the track you will pick when you assume that the table is table B. So you are joining a table to itself, making it seem like it is two tables, but it is just one. It's just that you will look at that table twice. You will look at the table as table A and then look at the table as table B. When it looks at the table as table A, it will look at the invoice ID. If the first invoice ID is 001, it will look at the tracks inside. If the track inside is track A, it will pick that track A and put it in the initial basket. Now turn around, because there's a left join, now turn around to look. The left join is like things that are in A that are similar in table B. So that means that it's going to look at everything in table A and then join it to things that are similar in table B. This is just joints. I did a video on joints. I'm going to put a link to that video so that when you understand how joints are done, that's inner join, left join, right join, and all that, you would understand what I'm trying to say better. So it's going to look at that table, all the items in table A, as we've given it an alias. So it's assuming that there are two tables of artist albums table. So when it is acting as artist album table A, it will pick an item as in an invoice ID, and that invoice ID, it will it will look for a track in that invoice ID. It will look for a track, maybe track A. Now goes to table 2, which is this table B, when it's acting as table B. Go and look at the invoice ID. That invoice ID that it looks at must be the same invoice ID that it looked at in table A when it was acting as table A. Now, if it's the same, it will now look at the track and say, oh, the track I picked for the first table, when it was the first table, was A. I cannot pick A. I have to pick another track, which will be probably, okay, let's say B. They are both in the same transaction ID, but the names are different. So you would now pick that one and put it in the second basket. So it will keep doing this repeatedly until it has covered all the transactions. So now these tables are created based on the invoice IDs, this which is the transaction ID. These are all this transaction ID is telling us the number of the transaction. You know, when you go buy something and they give you a receipt, your receipt number. So the receipt number in this case is the invoice ID. And when you see your receipt, you see all the items that you bought listed in that receipt. So that's exactly what it is here. All the items that you bought are in that receipt. This table is now going to attempt to pick all those items one by one, put them in two different tables, and do a comparison to see, oh, okay, these items are often bought together, these items are not bought together, and on like that. So that's basically what the query here is going to do. So now it's going to create those two tables based on the explanation that I've given. So if we run this, let's run this. We will see our two tables have been created. So if I had added the invoice IDs, if I had added the invoice IDs to this, you'd have been able to see that all these ones are the same invoice IDs. The ones that they join, they are from the same invoice. In other words, they are from the same receipt. So that's what happens when it's creating the two baskets, so that we'll now have two different baskets for them to compare. So now it's going to compare. These are from the same receipts. So it's going to come, let me use invoice because it's invoice IDs we are using here. So restless and wild, balls to the wall are from the same invoice ID. So it's comparing the two to see how many times or how often or What is the association between the two? Are they, is it that anytime this is bought, restless and wild, that customers that buy this always buy this, or this is just by random chance that the purchase together happens? So that's what it's about. In the initial basket, the first track is restless and wild, while in the second basket it is balls to the wall. So they would never be the same thing. None of the rows will be the same in the initial basket and the second basket. Now let's go to the next line of query. So now for this query, for us to find the frequency of both of A and B, for us to find the frequency of these two, that's the frequency that the two will be picked together or will be bought together, we need to do a count. So what we're saying is that count every time that restless and wide, balls to the wall appear together in one basket. You see why we needed to have two different items in each of the basket now, because now we have to compare to see if a customer bought restless and wild, did they also buy balls to the wall? If a customer bought Princess of Dawn, did they also buy For Those About to Rock? So now, so for that, that would be what we call the frequency, or because we know it is the frequency of both. So frequency, so that would be the frequency of these two tracks appearing together. So now if we run this, and then we are now going to, because this is an aggregate statement, we have to give it on the basis for which it is going to be performed. We're going to group it by A dot track name and B dot track name. So that's where this comes in. So if we run it, oh, I always forget this comma. We run it. So this is what we get. We see that 2 minutes to midnight, which is now the first item in the basket, and 04 running free appeared once together. A Melhoff for former and 32 dentes appeared once in a basket together, and on like that. I'm sure there are some that are two times and all. So that means that we have our frequency. To calculate support, we need the frequency of both products. So that is what we have here, the frequency of the two products. Now we want to find the total transactions. This line of query solves that. So to find the total transaction, all we need to do is to calculate the number of transactions in the artist album table. Our artist album table is our original table where all the transactions are kept. So we need to count all the transactions in the artist album table. And to count the transactions in the artist album table, you need the transaction ID, which in this case, like I said, is the invoice ID. So all you do is to count the invoices to get the total transactions. So if we run this now, we will get a new column. And that new column is the total transactions column. So now we have all the parameters we need to calculate support. But I want us to find all the parameters before we now start to calculate our association rules. So let's go to the next line. Now if I remove this and highlight that, now this says select count invoice ID from artist albums as AR. Remember that all our transactions are from the artist albums table. Now we want to remove a track from the initial basket because we want to count the frequency of, how often that particular track was sold alone now, not with the second basket, how often it was sold alone or how many times it was sold alone. And for us to get that, this is a new table or a new column. We're going to compare this column with the track name in the original table, which is the artist album table. So we're going to compare initial basket, the tracks in the initial basket with the track the track name in the artist albums table. So that means that we are using this table and this column. So what we are counting from is from the original table, which is the artist albums. And we are saying we are going to give it an alias so that it's easy for us to do the comparison. So we're saying that from the artist album table, which is now AR, check the track or pick a track. If that track is the same thing as a dot track name, we've given it an alias here. So that if it's the same thing as a dot track name or the track picked from the initial basket, count it. That's what we're saying here. So select, count, based, and we are doing our count on the invoice ID. So we're saying select and count the invoice ID that is the same as a dot track name, and any invoice ID where the track name is the same as the track name picked from here. Any invoice ID that you find here that the track name in here is the same as the track name is in here, count it and call it initial frequency. So the number of times that each track appears will be counted and placed in the column called initial basket. So that's what that line of query is doing. So now if we run that, we're going to add another column to our table. So all we're creating now is for the market B table. So this is the market B table. So you see that we have a new column, and in this column, it is only the frequencies of these tracks in the initial basket that we have there. Great. So now let's go to the next line of query. Just like we have done here to get the frequency for this basket, we are now going to get the frequency for this basket. So in the same way, we are going to compare whatever track is picked here with the tracks in the in the original table, which is the artist album table, and count the ones that are similar. So just like here, we are doing the same thing here, so that we will now have and put it in a column called frequency second basket. So if I now add this to our table, we now have the frequency for second basket. So that means 04 running was bought only once, while 2 minutes to midnight was bought 3 times. So it has 3 transactions are attached to this, only one attached to this. This one too, just one and on like that. So now you see we have all the parameters that we need to calculate our support, confidence, and lift, which is frequency of A and B, total transactions, which is this, frequency of A and B is this, then the frequency of the product on the left hand side is simply the initial basket. So the frequency of the initial basket, because this is the basket on the left hand side, so this is the initial basket, which is this frequency of the initial basket, and then the frequency of product B, which is this. So I'm going to bring this back so that we can now calculate the the support, our association rule. So now we're going to go back to this being a temporary table. So this is a temporary table. So that means this table ceases to exist physically. It will now be, somewhere in SQL kingdom. So it's a temporary table created somewhere that we cannot see. So now what we now want, if we want to see these columns, we have to bring it here. So we have to create a new table. Now this new table that we are creating has nothing to do with artist albums anymore. From the sales, we have already extracted everything we need from the artist albums table, so we don't need it anymore at this point. What we need now is our temporary table, the market B. So now we are referencing market B. So although market B is not showing here as a physical table, it is a temporary table that is lying somewhere in the memory. So now we're referencing it. We say select from the market basket, that's market B. We want to see the initial basket, which we're going to still you going to use to create our visuals. So we need the initial basket, the second basket, the frequency of A and B. And now we don't need all this anymore. We don't need to have them in our new table. What we need is the support, the confidence, and the lift. So now we've picked all this. These ones are quite straightforward. Initial basket this, second basket this, and frequency. Now we need to calculate support. And you remember that to calculate support is frequency of both products divided by the total number of transactions multiplied by 100. So which is what we brought down here. That's frequency of product A and B, which is what we calculated earlier as frequency here. So we need the frequency multiplied. Here, what I did was, rather than first of all do the division before multiplication, I did the multiplication by 100 first. So I multiplied frequency. Ignore as float for a moment. Ignore this cast around. Ignore as float. Just assume that this is frequency times 100 divided by total transactions. So if you do that, you already have the support. Now we had to cast it as float because if you notice, all the numbers we have here are whole numbers. The values we have here, they are all whole numbers, they are integers. So now if, for instance, we say the frequency of both is 1, we now divide it by 1984, for instance, and it gets a decimal, it gets like a decimal number. It's supposed to get decimal number, right? But it's so funny that SQL may just decide to truncate it and remove all the decimal points and present our answers as a whole number. And we don't want our answer to be presented as a whole number. We want to see all the decimals. So that's why we're saying cast it as float. That means that turn frequency. You're going to turn this one into a float, which is 1.0. So that means that this has become a decimal number. That's what the cast is doing. So cast is as float means that turn it into a decimal number. And then the same way, it was 100. So we are multiplied by 100.0 because we've turned that into a float as well. So if we multiply this and then divide by total transactions, we'll get the support. So you can, this is the same thing as doing this, as dividing before multiplying with 100 is just math. So here we already have the support. So now this 2 is telling it if, for instance, by the time the division is done and our answer is 0.00357, on and on like that, we don't want to see all that decimal. Reduce it to 2 decimal places. That's what this is saying. So that when we say round it to 2 decimal places, so that's what the support will now show us. Let me take all this out first so that we'll see what the support, what it becomes line by line. So now if I run this, you see that we no longer have these 2 values. We don't have this anymore. What we now have is this table here. That's what we are dealing with now. That is our output. So we have the initial basket, second basket, frequency, and then the support that we just calculated, which is it. And now look at the support. If we had not cast it to float, imagine it just dropping 0 and taking off this 0.5. It would not make sense. So now this 0.05 gives it more context. Now let's do the next line of query where we are calculating the confidence. So for confidence, it is still the frequency of both products, which is this, divided by the frequency of the first basket, that's the basket on the left hand side, which is this, and then multiplied by 100. So just like the other one, I multiplied the frequency by 100 before dividing by the frequency of initial basket. And just in the same way, we cast it to float before the multiplication takes place. for the same reasons, and then round it to two decimal for the same reason. So we have the confidence. So let's run that part. So now we have a new column, which is the confidence. So the next line is to look for the lift. So lift, like I said earlier, is this. I just broke this down. Support of A and B divided by support of A times support of B. So which is just, this is the breakdown, because these are what we have, the parameters we have. So we're just going to slot it in like that. So just like here, we know that this is the support of A and B. So which is what we have here, support of A and B. And here we'll now bring in the support of A. This is all support of A. This is support of B. This is support of B. Now, once you get the support of A and the support of B individually, multiply them together. Once the multiplication has taken place, then we can now do this division. That's this divided by whatever value we get here. So that value that we get finally, we now round it to two decimal places, just like we've done before. And then we have the lift. So if I add lift to our table, so we get our complete association rule. So this is the support, the confidence, and the lift. So the interpretation of this is that for support, 0.05% of all transactions include these two. That's 2 minutes to midnight and 04 running. That's what we have, 0.05% here for support. For confidence, it means that with all transactions where this was bought, 2 minutes to midnight was bought, 33.33% of them contain 04 running. So that's what this confidence is saying, which is relatively high. But of course, 50% and 100% are a lot better. For lift, 6.61 indicates a strong positive association, meaning that these two products are bought together much more than if they were independent. Because you have this, the lift is 6.61%. Of course, a lift of 19.84% is a lot higher than 6.61%. So with this insight now, you see how a business can easily, they can do cross promotion with this. They can focus on peers with high lift and high confidence and put them, close together. They can also do bundle offers. So this kind of this is why the association rule is important for businesses, particularly retail businesses. Now let's take a look at market basket quickly for the albums. Now the process is the same. However, there are slight differences. In this business, what they sell is the tracks, not the old albums. So that means transactions are recorded according to tracks. So if we now say that we should do a count like we did here, we're going to be counting some albums more than once, because in a particular, for instance, a particular transaction now may have more than one track of a particular album in that transaction. So that will be like double counts. So instead of doing a count like we did in tracks, based on the fact that the transactions are recorded according to tracks, here we are going to do a distinct count, so that the distinct number, the unique occurrences, that's where you're going to use we are going to be interested in the unique occurrences of each album. So that's just the only difference. We're going to use distinct counts instead of just ordinary count. So it's just the same, and then the process is exactly the same. So for market basket for albums, this is what the final results would be. So the initial basket, we'll create two baskets just like we did in for tracks, and then do the total frequency. The total, you can see the total transactions is a lot less than what we had in the market basket for tracks. For tracks we had 1,900. Okay, it's not showing anymore. It was like 1,984. But for here we have just 368. So and then we calculate the frequency of the of each basket like we did there. So if we run this, we will now get our final table for confidence, support, and lift. Can see the lift for these ones are less than 1. So you can see that the lift for these ones are less than 1. So a lift of less than 1 actually just decreases the likelihood that when a real dead one is bought, for instance, there is less likelihood that they would also buy a matter of life and death. The confidence is saying 50% of customers who buy a real dead one will also buy a matter of life and death. So that's what this is saying. Confidence is good. Even the support is a lot better than what we had for tracks. But the lift, it decreases the likelihood that when a customer buys the initial basket, they will also buy the second basket. So based on this analysis, we see that, you know, doing the market basket on tracks make better sense for this business than doing it on albums. So that is how to calculate the market basket. And after our calculation, we just download it as usual and then take all the tables to Power BI. So we've created tables like the artist album table. We've created table for the CLV, that's customer lifetime value. We've created tables for segments, that's a customer segmentation. We also created tables for market baskets. So now we're going to take all this table to Power BI for visualization. So I'll just show you my Power BI visualizations in the next video. So thank you for coming on this journey with me so far. Please remember to subscribe to the channel so that you don't miss any of the videos. Thank you.